Hi, everyone. Welcome to this exciting time. As you can see, I'm sitting outdoors in San Francisco at Moscone Center. To your right, you can see this iconic San Francisco Museum of Modern Art. To my left, if I pan, is the famous Marriott Marquis, which we affectionately call the jukebox. But why are we sitting here in rain on dark and gloomy day is because the excitement of Microsoft Ignite. So here's my badge. I'm at Microsoft Ignite 2025 in San Francisco with my good friend Carol. And today we are going to talk about all these new developments that we are hearing about, especially on the data side, because there's a lot of talk on agents, but agents can be only as successful as your data and how clean, recent, and easy to consume it is. So with that, I'm going to not steal any more thunder. Kirill Gavrylyuk is my guest on this podcast today. Kirill, so great to have you.
Great to be here. Thank you, Sanjeev. It's really exciting times. I'm really glad Microsoft is back of doing 20,000 strong conferences. Ignite and San, it's great time to be at San Francisco. We have many announcements at Ignite, many customer conversations. The energy, the vibe is amazing. I've been with Microsoft for many years. Last decade, I spent with non-relational databases. We're running Azure Cosmos DB, Azure DocumentDB that we announced just this yesterday morning. It's exciting times to be in databases.
So how long have you been with Microsoft by now?
Oh, 25 years. I started in SQL and I did the whole 360 back, and I've been in distributed systems. I did the mobile services, Sanjeev, you probably remember. We talked about it a long time ago. We did mobile backends, a lot of work on app developer, making things easier for our developers. And last 10 years I've been with CosmosDB. It's exciting times.
Thank you so much. This conference is huge, as you said. In fact, it's so big that all the participants couldn't even fit into Moscone Center for the keynote. So we all hiked over to Chase Center, which is this gorgeous Golden State Warriors stadium. It's fairly new in San Francisco and had this amazing keynote. The day was brilliant, sunny, but today I'm very curious. You've been to so many of these events. What are your highlights and what are some of the things that surprised you? Before we go into any of the announcements, I just want to get a general view of this year's Ignite.
Yeah, absolutely. Well, as many have observed, there was a lot of AI in the sessions, right? So word AI is almost every session. My team proudly has one session that has no AI in it, and I'll talk about it later. I mean, the exciting part starts from the bottom of the stack, right? We had the number of exciting announcements on databases across 4 databases. We announced Azure DocumentDB. We announced the new Postgres service, HorizonDB. Very exciting. SQL 2025. Let's not forget that is the foundation of Microsoft, has been for a while, one of the main pillars of Microsoft business. And SQL 2025 comes with exciting, it's amazing features. It's like years ahead of many database engines. Now going up from there, we have interesting announcements in Foundry and Fabric. Foundry IQ and Fabric IQ, adding semantic layer on top of the data, on top of AI to help agents reason better about what's in your data state. I think it has a lot of potential. I know I'm really excited. Ontology work actually started in my team a long time ago, and we took some of the lessons that learned inside LinkedIn on LinkedIn Graph, made its way now and offered as a Fabric IQ, and it's I think it's a great, it's very, very, very interesting work. Again, LinkedIn uses this at a graphs of a tremendous scale, and it's great to see now it's available to customers to leverage as well, this technology. And of course, Foundry IQ. Pablo Castro is a friend. He's did very, very interesting, very amazing work on the semantic layer. And then wrapping it up with App Builder. I think that was actually a surprise to me. like we all, there's so many announcements take the Ignite. We all find something that is new and we didn't know about. So I think App Builder taking shape. I think it's a pretty strong offering now, and it's kind of evokes a builder, creator in all of us, right? Whether you write code, whether you build things before, or whether you are, working on your marketing presentation. App Builder allows all to take advantage and build great things on Microsoft platform.
So I want to go into databases, but App Builder, I just want to clarify this. There is Agent Builder, there's Agent 365 that got announced, which is a control plane. Is App Builder for AI or is it for database? Like, is it for writing SQL,
It's for
stored
AI,
procedures?
yes. This is
I
the
see.
agent app builder, like where you can compose multiple agents together. It's like I think they embrace the multi-agent paradigm, and it's a very interesting offering.
So got it. So let's start with the databases. So many you mentioned four of them. I want to go one by one. DocumentDB is something very intriguing. So what is DocumentDB? Where does it come from? What's its purpose?
So we've built it inside CosmosDB. Like generally speaking, the non-relational spectrum of use cases can be divided in two. There is a scale out first. Lots of it's like we call it key value plus plus. These are the databases like DynamoDB, like CosmosDB, like Spanner, where you have scale is first. It's really good at really large volume of relatively simple queries, really large volume of transactions, optimizing for high availability, 5 nines. This is what you build your mission critical systems on. And then you have document databases that are really good at very rich queries, aggregations, semi-analytical queries that bring a lot of compute per gigabyte of data, right? And so this is MongoDB has been reasonably successful in this segment, and Azure DocumentDB belongs to that category. So we originally built it as part of CosmosDB as an engine for these document-oriented scenarios, and we spun off as a separate service. We open sourced the engine, and that's an important part of our strategy. I don't think anyone sells software anymore, right? I think all of us, like, we want to collaborate on software with others, with everyone, and then build services on top and compete on services. So that's generally the idea. Postgres is the most successful database, and the reason is because it's vendor neutral and it's open source, and no one is selling Postgres per se. Like we all build services on top of Postgres and offer them as a service and compete on that, right? But on Postgres, all hyperscalers are collaborating. We're all contributing to Postgres, and everyone is happy about it. DocumentDB is the same idea. We all like MongoDB API. It's a popular API. Developers like it. We like non-relational databases. In the age of AI, forgive me for marketing term, but it's true. Semi-structured data becoming ever more important. All the chats, all the metadata about the documents, about information, all the multimodal use cases, they all require semi-structured data. And non-relational databases are the best at semi-structured data. So we want the non-relational database to continue to grow and proliferate. But the MongoDB API right now, like it was sort of because of the reasons which I respect. The currently MongoDB is closed source, controlled by a single vendor. It's not as open. It still doesn't follow the same path as Postgres, right? So the idea of DocumentDB is to help the ecosystem flourish, right? So it's a MongoDB compatible, open source, permissive license, vendor neutral database engine governed by Linux Foundation. We contributed it to Linux Foundation. Amazon, Yugabyte, others are contributing very actively. We have the folks like AB and Bev, which is the Anheuser-Busch
a beer company.
Yes, they also contribute to DocumentDB, right? Have many, it's a community, and it is based on Postgres, but it's carefully integrated using the phenomenal accessibility of Postgres. It's replaced the query index with a document-focused indexing and query layer. And on top of it, we provide MongoDB translation. It is very performant. It can do, it's a scale out. It's a scale out database. It's really good for any MongoDB queries. It's amazingly compatible. Like compatibility is 99.4%. I think that's the idea, was to build this as a community and then build services for it. And Azure DocumentDB is one of the services that leverages open source DocumentDB engine. And now you can do multi-cloud deployments. You can do hybrid deployments. We just demoed on Tuesday, we demoed the a DocumentDB cluster distributed across 3 clouds, Azure, AWS, and GCP, running on kind of managed service in Azure and Kubernetes services on AWS and GCP, and providing a strongly consistent 3 cloud deployment, which is something that is rare and now is available as an open source.
So a couple of clarifications. One has to do with what is the backend engine? Is it Postgres?
It is built on top of Postgres, but the indexing and query is optimized replaced through extensibility to optimize for document-oriented scenarios. It has 3 extensions. It has the extensions that makes BSON the first class type in Postgres. It has an extension that replaces indexing and query to optimize for document queries, document-style queries. And then it has the MongoDB, very thin MongoDB translation layers that translates MongoDB protocol to queries and to effectively to Postgres queries.
So the second question I have has to do with the nomenclature. It's been a bit confusing for those of us who've been tracking this space for a long time. Microsoft had a DocumentDB, which was a document database, and then it somehow got dropped. It became CosmosDB. AWS, in the meantime, launched DocumentDB, which was their MongoDB compatible, and now you have an open source DocumentDB. So can you educate us on why are we using the word DocumentDB across 2 different cloud providers, and what happens to AWS's DocumentDB, which is now overlapping?
Absolutely. Well, we all like DocumentDB. I think that. But yes, so DocumentDB is basically this document database, right? It's and that's what we like. We like descriptive names. Like there's no, it's easy to understand what the service does. And there's so many services these days we release every year. So we wanted it to make it easy for developers. DocumentDB, Azure DocumentDB and Amazon DocumentDB are similar architecture. It's very similar architected. They use currently they use slightly different engine underneath the covers, but very similar architected, and they're actively collaborating with us on open source DocumentDB. And so they will, as they said, they will take advantage of open source DocumentDB inside Amazon DocumentDB engine, a service. So we are all converging on the same engine, the same software, just like we do in Postgres, right? So that it's the same class of same type of services, similar offering. Hence same name helps it make it less confusing for developers. And really, we target that it's a reality that most customers have 2 clouds at least, right? And dual cloud deployments have become very, very popular. And making them easy means the more we focus on leveraging the same open source software, but build great services on top, the easier it is for customers to port. And portability becomes either enforced by regulations or generally just demanded by customers. And we want to be where customers want us to be.
That is great. So, and I can run DocumentDB on premises.
Absolutely.
As a like in a Docker container and
in a Kubernetes, or a Docker container, or on a Kubernetes cluster. We offer a Kubernetes controller now, or a Kubernetes operator. With DocumentDB Kubernetes operator, you can have a distributed DocumentDB. We showed how you can promote one cluster on top of the other, and this way you can fail over from cloud to on-prem. That is
great. So moving on. The other new thing that actually DocumentDB, we've been hearing about it for the last few months, but HorizonDB was brand new. What exactly is HorizonDB? I know it's Postgres, but the first time I heard about it, I thought, oh, maybe this is Microsoft Azure version of what AWS has called Aurora, and then Google has Alloy DB. Is it the same idea, or is it something different?
It definitely belongs to the hyperscale databases class. Yes, it's the similar class to AWS Aurora and GCP Alloy. Obviously, every time you do something, you innovate and you bring new things, and you have advantage of leveraging, building on the latest and greatest foundations. So with Horizon, there are notable differences from Aurora, for example, because we have advantage of being able to work with the latest versions of Postgres. We don't have to compensate inside our stack for shortcomings of Postgres 13 or 11. Then we don't need to fork like AWS did Postgres back in the day because of some of the gaps that they needed to compensate for. We can take advantage of the fact that Postgres now has async in it, right? We don't there's a lot of performance improvements, scalability improvements that we can build on top. So it is Postgres. It is the most compatible hyperscale Postgres offering. It is Postgres as is. We did not fork. We do not change anything. It is Postgres as is. But it is a hyperscale offering, meaning that we can scale out storage to 100 and I think we said 150 terabytes. We can provide sub-millisecond write latency using kind of the segregated storage and separating the wall from the storage. We can scale out reads to any scale needed by adding read replicas. So it has similar characteristics and better performance in many places because it's much easier for us to take advantage of latest Postgres and work with latest Postgres as opposed to forking and compensating and writing something on the side.
When a new Postgres version comes out every year, I forget, is it Postgres 15? Sorry, what?
No. It's 17 right now.
17. So when a new version comes out, how long does it take? Because if it's you separated the compute and the store, right? Because the storage is scale out and highly distributed. The compute is native Postgres. How long does it take for you to get to the new version? Like next year when Postgres 18 comes out, how long? What's the time frame?
Oh, it's actually very fast. So we recently released the Postgres on Azure within 24 hours of new version of Postgres released to the markets.
Oh,
That's the
wow.
advantage of not forking, not having to fork, and using Postgres as is fully. Obviously, for hyperscale scenarios, we have to manage which extensions we allow on it, just like everyone else. But we take Postgres as is, and so we're able to round trip amazingly fast with Horizon.
Yeah, that's great. And then you also have your own vector technology, DiskANN, for vector embeddings and indexing. Can you tell us like what it, because Postgres comes with PG vector, and then there are standard indexing like HNSW, quantization, IVF. What is DiskANN? Where all does it exist in different databases inside Microsoft?
Yeah, absolutely. So DiskANN was originally invented inside Microsoft Research. Actually, the DiskANN inventor works on CosmosDB team, Harsha. He's a fantastic, amazing. I should introduce you to him. Amazing, very humble, very kind person. So DiskANN, I'll tell you kind of a little story. So when the Microsoft 365 Copilot first came out, initial version was using kind of standard off-the-shelf HNSW, and very quickly COGS mounted. Became like it was very clear that kind of committing so much memory per tenant, per each customer, it's like just not practical, not gonna fly. So DiskANN is invented inside Microsoft to address that challenge. The challenge of doing the vector search at scale, at Bing scale, at the Office 365 scale, at OpenAI, or like let's say at Copilot scale. DiskANN is very efficiently uses local SSD drives in combination with memory, and it only loads in memory quantized vectors around the neighborhood, and walks the graph very efficiently. It has a good technology of graph management that makes it very robust to changes in the graph, changes in data. So it makes graph mutations very fast, maintaining the accuracy. So in terms of like the accuracy per ingestion rates, DiskANN is a leading vector offering today. And it's very cost effective for large scale scenarios. A good story just at Ignite issue. The session is going on right now. Veeam software is a backup software. They needed to deliver a discovery service that allows people to search their backups. It's a tens of petabytes of backups. And the way they do it is they vectorize and they use DiskANN. And despite the scale of tens of petabytes, with DiskANN, it was about, I think he said, 30 to 40 times cheaper than any off-the-shelf like HNSW or any other vector index implementation because of that cost efficiency of doing scale-out graph search. The other part of it is it's also very simple to get started. Like if you want to use DiskANN with CosmosDB, for example, loading 100,000 vectors and doing 10K queries per second costs you about $3. So it's very cost effective.
That is great. I want to actually move to CosmosDB. That's your baby for so many years now. But before we do that, since you mentioned a customer example, yesterday I ran into some guy from DocuSign. He has a talk today. And is there something that I was surprised the entire DocuSign product runs on Azure. Is there anything you can share with us, like any databases? Or...
Yeah, absolutely. DocuSign is a great example of how use Azure database platform together. So they use CosmosDB and SQL. They use CosmosDB to capture it's a brain of their, like I think Kunal Mukherjee calls it the brain of their agreement systems, right? It has all the metadata, all the semantic layer of their agreements, and they handle billions of signers, right? It's a massive service. And they use SQL to transact, to capture, to do transact agreements. Obviously, asset guarantees are very useful in that case. And while Cosmos does asset guarantees within a partition key, it's a scale-out system. SQL is a scale-up system. And so we can, if you want to do, I think it's a great assets database. So that's like, it's a perfect example of using SQL and Cosmos together. DocuSign also needs good hybrid search capability, right? And so they use CosmosDB for search for very similar reasons that Veeam did, because of the multi-tenancy, multi-tenant scale, and multi-tenant cost efficiency. And we've done a lot around multi-tenant use cases in CosmosDB and some of the announcements we can talk later in our discussion.
That is amazing. I literally just ran into some person in the line. So thank you for educating us. We've talked quite a bit about CosmosDB. CosmosDB is actually, in my opinion, such an amazing database because everything that we do in like ChatGPT gets stored in CosmosDB. Everything we do in Teams gets stored in CosmosDB. So can you tell us what is CosmosDB? How is it different? How does it scale out? Who's using it, and what new features were announced at this year's Ignite?
Absolutely. So CosmosDB, it is our database for hyperscale scenarios, right? This is a database where that OpenAI runs, that 70% of all Microsoft Cloud usage runs on CosmosDB, that all Walmart transactions, e-commerce, all of it runs on CosmosDB. It's like all large scale offerings that need 5 nines reliability that run on Azure. Use CosmosDB for that reason, right? And CosmosDB continues to prioritize two things. One is it's a mission critical offering, right? So we continue adding more capabilities, features, like we added the ability to do 5 nines active, no matter what consistency you use, eventual or strong, for example. It was a very interesting kind of zero loss, zero touch, zero downtime. We continue to, but AI scenarios brought a lot of interesting use cases. CosmosDB is used as agentic memory at scale, right? So that is a memory of ChatGPT. Chats, what it knows about you, your context, everything stored in Cosmos. That is the agentic memory behind most of the agents. It's behind the AI Foundry. It's based on AI Foundry memory. It's based on the many of our first-party offerings, agentic offerings, and memory, semantic search, multi-agent scenarios. That brought a lot of the fact of the semi-structured data, first-class semi-structured data support that bring Cosmos DB to light in these use cases very easily. But Cosmos DB continues to be used across all segments, all verticals, especially as more and more software is offered as a service in a multi-tenant way. Cosmos DB is our multi-tenant database, kind of probably one of the best multi-tenant offerings that we have. And so at Ignite, we announced Cosmos DB Fleets, and Adobe, which is kind of the leader in personalization, right? So Adobe has runs brands like Microsoft.com, Home Depot, like Amazon.com uses Adobe, right, for real-time personalization. They're solving interesting problem. If you land on a website, they want the website to be able to offer you personalized experience within 100 milliseconds. So you immediately get the right promotions, the right experience that guide you to your goal, to what you will likely want to do in the fastest way. And that 100 milliseconds is enabled by Cosmos DB. Adobe uses Cosmos DB. But doing this at scale, where every site has peaks that are 10x size or different dates, is impractical if you're using kind of classic provision on VMs, all your databases, all your 10,000 tenants. So Adobe uses Cosmos DB Fleets to share throughput while maintaining full secure isolation for every tenant. So every tenant is in their own Cosmos DB account, is encrypted with the customer keys, fully secure, but the throughput capacity is shared across those 10,000 tenants. So Adobe does not need to provision or pre-provision anything. Any tenant needs, it takes from the common pool. And every tenant can be up and running at whatever scale needed on Black Friday or holiday season.
That is quite fascinating. Which, as I was listening to you, it just took my mind to real-time streaming, the RAG use cases where I need to look things up in real time. How is all of real-time streaming? Because Microsoft Fabric has been a huge focus at this conference, and it has RTI, real-time intelligence. What is the connection between real-time data in Cosmos DB and then joining it with historical data in a data warehouse and doing analytics?
Well, it works very well together. RTI is an important use case for Cosmos DB as well. And so Cosmos DB typically uses an RTI stack as either a guaranteed speed of ingestion service or as a serving layer, low latency serving layer, right? Or as the current state, like device twins, the current device profile. Those are the three scenarios. It's very good at storing semi-structured data and low latency retrieval. And if you need a guaranteed ingestion within milliseconds or 100 milliseconds, so you use Cosmos DB for that. Because Cosmos DB now is in Fabric, so together you use RTI with Cosmos DB together. Those integrations become even easier. But many customers are using them in conjunction. It's like Cosmos DB and Event Hub used to be the most common combination at Microsoft back in the day. And now they're all in Fabric. And so you can it's even easier for customers to take advantage of this.
That is fascinating because Cosmos, it used to be there's operation database, analytical, you had to ETL or zero ETL, but somehow you need to move the new data from write-ahead logs into analytical, but now Cosmos DB sits inside Fabric. What does that mean? And how quickly is that data available to the analytical side?
So data is available in Fabric pretty much instantly, within a minute, by virtue of Mirror. Whether Cosmos DB is...
Can I say, within a minute is still pretty long? Like, is it milliseconds, seconds, or is it...
No, it's at the certain percentile. Like if you're running a million transactions per second workload, laying out, syncing the Cosmos DB to the Parquet files takes at the P99 percentile around a minute. And that's that has to do that we need to be, because when we do that, we do not take anything from the operational store, right? There is no impact on the performance of operational store. There is no impact on the queries. It's completely transparent to operational store. That's why we have to do it kind of carefully to not disturb. Like the operational database has to continue to provide the guarantees that it provides. But the data automatically is made available to you in one lake at P99 percentile, and within a minute. And that is, it's available to you whether you run Cosmos DB outside of Fabric or inside. There is really not much different in Cosmos DB per se. It's the same Cosmos DB. It just when we offer Cosmos DB in Fabric, we make those integrations very tight. Like you can create Cosmos DB collection inside Fabric without having to go through lengthy portal blades. You can create, you have the data automatically in one lake. You don't need to configure mirror, right? It's automatically happens. You can like all your data is guaranteed to be in one lake. You have integrations with like Power BI forms, integrations with RTI, with the kind of data functions, with the pipelines, right at your fingertips. So it's really, if you're building solution within Fabric, then and you need a database. Schemaless databases are very popular, so you can use Cosmos DB right there. But even if you're building an app on Azure and you need analytics, Cosmos DB Mirror is a very fast way for you to sync to one lake, which is the ADLS store, and then party on it. And so we have many customers that do this pattern, and the reverse is also true. That's real-time personalization use case that I talked about with Adobe. It's everywhere, right? And so like, who doesn't want real-time personalization? And the way it's done is that you mirror your data to one lake, you cook your data, you do some computation, etc., and then this recommendation matrix that is super valuable, you sync back reverse ETL to Cosmos DB, and we make it very easy because we control both ends. And now you can serve it within a couple milliseconds from Cosmos DB to your app.
That is amazing. I didn't think about the reverse ETL. So it's a complete feedback loop as well.
Full loop, yeah. And it's very, very important, very important. It's like that use case is now everywhere because everyone wants highly intelligent analytical platform, computing at least high value data, and then serve it within milliseconds, right? And so that reverse ETL is we make it super easy to go the other way.
Amazing. So before we move off from databases, I'm very curious about other open source databases we haven't talked about, like MySQL is one of them. What is your support for MySQL? And also search engines are really big. Like OpenSearch is a fork of Elastic. And it's also part of Linux Foundation, just like DocumentDB is. How are you handling search? And is there going to be an Azure support for OpenSearch? But before that, let's start with MySQL.
Well, MySQL has an immense customer base, right? That has been a database out there with a large customer base, large deployments for a long time. I think the MySQL is a good example where we get things wrong when a single vendor starts to control too much of it. And the MySQL versus Postgres dynamics and how Postgres has won effectively, right? And kind of took a lot of share from MySQL is an example of it. It has nothing to do with the quality of software. MySQL is a great database. It has to do with vendor neutrality and permissive licenses. Right, and I think that's very important. So anything we do, we believe in this software should be done in permissive license, open source, vendor neutral, and then we build great services and compete with everyone else to build best services on it. OpenSearch is a good question. I believe that search is such an ubiquitous capability that it will be present everywhere. And that's what we did. We put search in every data service that we have. And we use the same IP, like the DiskANN is in Cosmos DB, is in Postgres and Horizon. It's in it's in SQL 2025 in the SQL server. It's everywhere, right? It's in Fabric. And We have obviously AI search, a great product that does kind of dedicated if you have a bunch of data at rest and you want to search over it. But we think search is ubiquitous, and we are open sourcing search. Like, and the latest DiskANN version will also be open source. It's just a matter of kind of cleaning up and getting it out. Like that software, we don't intend to hold IP on this, right? It belongs to community, but we use it everywhere. So I don't know if it's that important for Microsoft to be part of Linux Foundation Open Search per se, because it's more of a vertical stack. It's the entire offering, versus we want to contribute the software, the algorithms to the community, and have community do anything they want with them, because then you can build a lot more things with composable architecture as opposed to open sourcing a monolith. That's my view.
Yeah, no, this is great. So thank you for sharing that. As we get close to the end, I want to change tracks, and I want to talk to you about some interesting business use cases. You already mentioned Adobe and DocuSign and some other great ones. What are some other ones that stood out for you? Or are there any use cases that surprised you with how they're using your technology?
Yeah, great question. I think definitely the things people do with agents and the technologies that AI triggered to develop, that ceased to amaze me. Like we have folks that do analytics on what people watch on TV by vectorizing frames of the show, right? And that's like vectorizing frames as in doing a vector search across shows to know exactly what everyone is doing, so that they can provide more personalized experience when you watch something. We have folks do using vectors in manufacturing to ensure quality. Like now you can do by taking a photo of something, you can compare and know exactly what fabric it is made of, whether it matches the quality, and just from a single photo, you can recommend, for example, what to do with a particular crop in a particular farm remotely, just by taking a picture and submitting, right? And it's all enabled by this vector search capabilities, right? That were built because of the AI pressure. We can I think, multimodal queries. That's what we're building. Like inside CosmosDB, we have multimodal embeddings and a single index that captures what you have in the video frames, in your documents, in your pictures, and tying it all together, allowing you to do amazing things, right? You can do kind of queries across your multimodal data estate. I think those are interesting technologies that agents will. The other, I would say, what I see is agents do a lot of exploratory queries, and I think there is a Berkeley article about it, where we will see a lot more repetitive queries in agentic world, and so databases need to build up their caching capabilities much stronger. And so we have we have the open source technology called Garnet, and we're doing some interesting things with the integration cache inside CosmosDB on it. I think those are use cases that are fascinating, kind of how it all evolves. Obviously, it's not just agentic applications itself, but also technologies that agents trigger that is now then used in all kinds of use cases that weren't possible before.
This is fascinating. I think it's a topic for another time to talk about this technology, because when Databricks bought Neon database and it becomes an agentic database, so we'll pick it up again. I'm gonna wrap this up. It's been amazing, but before we go, I'm very curious. Tell us something that is a hobby for you and something that you like to do outside of your work life, and what are some of your passionate projects?
Oh, absolutely. So I love building things. And so
okay.
my son and I, we got really fascinated with this microplastics problem.
Oh,
Like it's everywhere, right? So like now
yes,
you
correct.
can't eat a fish without consuming microplastics,
Yeah,
unfortunately.
yeah.
So I think my son is 10 years old. He's very curious. So we built this microplastics filter robot that you can unleash on the lake, and it goes and does filtering. So like I think the things that you can do today with the and now you can do add some AI to it, so it can be more smarter as it navigates the lake, and smarter when it filters things. Like there's a lot of interesting combinations that you can do with it.
That is fascinating. I had no idea about that. So thank you so much for sharing all your insights. I loved hearing about how this technology in the data space is expanding. Once again, it's such a pleasure to know you for years, and thank you for coming to this podcast.
Thank you, Sanjeev. Thank you for having me.
You're welcome. Thanks. Bye.